Hey you guys, what is going on? It is your good buddy Sam, and it's time. It's time for another exciting Max MSP tutorial. Man, I can't tell you how good it feels to say those words after months. It's been a long time. What can I say? I'm really sorry. I don't have a good excuse other than just debilitating laziness, like pathological laziness, laziness that should be in the DSM, DSM-7, DSM, whatever we're up to at this point. My point is it's lazy and it's bad, but let's put that behind us and talk about the big new hotness, Max 7. Max 7's been out for about a month or so now. It's really great, and I can't wait to talk about all the cool new stuff that is packed into Max 7. So let's talk about processing. Processing is what is processing exactly? It's a rapid prototyping front end to OpenGL, really, which is the guts and glory, the back end that does all the heavy lifting. So it lets you make very pretty things and experiment with making pretty things quickly. So it's a fun tool to use with Max, and over this tutorial, and hopefully the course of a couple more, I'm going to show you how to make processing work with Max, which basically, you'll be king of art if you can make Max work with processing. So how does processing work? Basically, you call two functions, setup and draw. Setup sets up your window, picks your colors, and in draw, you decide what shapes you want to draw, where you want to put them, all that kind of stuff. So let's look at a quick example. I'm going to declare my setup function like this, void setup. Bit of syntax, void up here just means that setup is a function that returns nothing. You have to say void because processing is based on Java, and Java is terrible. Setup is the name of the function. These parentheses means that setup takes no arguments, and everything in these curly braces here is the function itself. So we're going to start our function off just by calling size. And this tells you how big the window ought to be. It doesn't matter, we're going to make our window resizable, but it can start out at 480, 320. And then we'll make it actually resizable by calling frame, which is your reference to the window, set resizable to true. Then let's make the background color 0, which is black. Let's set the stroke color, which is the outline color of all our shapes, to be white, 255. And then finally, and most importantly, let's turn on no smooth. No smooth turns off anti-aliasing, which will speed things up. It lets us draw a lot more stuff. It also has the side effect of making all our shapes look really pixelated. But you know something, man? It's 2015. Pixels are cool again, you know? Hashtag new aesthetic. So don't be a baby. Embrace the pixels, man. They look cool. Okay, now void draw. This is the loop that will be called once per frame to actually do our drawing. The first thing that we're going to do is call background 0 to clear everything out and just draw the background color. And then let's actually draw something. And why not draw nature's most perfect shape, the circle, or aka the ellipse. So we'll do ellipse, and we'll draw an ellipse centered in the window. So to do that, we do width divided by 2.0, so half the width of the window, height divided by 2.0. It's going to be a point in the center of the window, and let's make our circle 100 pixels in radius. Push this run button, and there it is, our little non-anti-aliased circle floating in space. It's beautiful. It's the first thing we've ever drawn in processing. Should be proud, proud parents of our little egg. So, having drawn that egg, let's get crazy. The cool thing about processing, as opposed to Max, is that it lets you iterate. So say, for example, I wanted to draw 1,000 lines. Max might be a little bit tricky to set up. Processing, it's super easy. Let's declare a variable up here with type int called line count. And let's set it equal to 1,000. Why not? And now instead of drawing one ellipse, let's draw 1,000 lines. The way that you draw a line is you call the function line, you tell it the point where you want to start in x and y, and the point you want to go to in x and y. And what I want to do is start at one point, draw a line to another point, and then pick another random point to draw from that, and so on and so on, so we get this kind of jaggedy, lightning-looking line. I'll show you what I mean. So let's declare up here and draw two variables, both of them float. Float is a type that means not an integer, so a number with a decimal component. And there'll be two of them. One will be called AX, and we'll set that equal to width divided by 2.0. So the center of the screen in X, and float AY, which we'll set equal to height divided by 2.0, which is the center of the screen in Y. Now, the good stuff. This is what it's all about. For int I equals 0, so declare a new number called I. Keep doing this loop until I is, keep doing this loop so long as I is less than line count. And every time you do the loop, I++, add 1 to I. This is the power right here, you guys. This is where all the magic happens. So first thing we're going to do is create a new point that is some random distance away from the original point, AX and AY. So we'll do float BX equals AX plus random minus 10, 10. So AX is going to be, no, sorry, BX is going to be AX plus a random number between minus 10 and 10. And floats BY will be equal to AY plus random minus 10 up to 10. Cool. And then we'll actually draw the line. So let's see, line AX, AY, BX, BY. Last but not least, and also kind of most importantly, move the current point to be equal to the new random point. So I want to draw the point from AXAY to BXBY, but then the next time I loop, I want to start from BXBY. So I'll set AX equal to BX and AY equal to BY. And that should be it, man. Let's run this and see. Look at that. So, okay, is there a way I can freeze this at a given... should have thought this through. Well, hopefully you can see that every frame, it's changing every frame, and so it looks really chaotic. But it's starting from the center point and then sort of drawing a lightning bolt, like a random jagged line, moving generally away from the center point. One thing we can do is sort of play with the intensity a bit. If we come into draw here, let's declare a variable up top here called intensity. Intensity. Set it equal to 0 to start with. And then here in draw, let's set intensity to be equal to mouse x, which is the x position of the mouse, so whether it's at the left half of the window or the right half of the window, divided by the width of the window, which just scales that to be a number between 0 and 1. We should probably cast this to a float. Don't worry about this, just do it. And let's multiply that by 10, should be okay. And then down here, instead of going from minus 10 to 10, let's go from minus intensity all the way up to intensity. And then let's see if we can just copy that down here. Cool. And now let's run this noise. And so see, as long as my pointer is at the left side of the window, the intensity is really small. And as I bring it further and further to the right, shit gets cray, as they would say in the East Bay. So that's looking pretty good. Now, of course, that's fine. It's fine. It's on its own. Totally passable sketch. Obviously, you could sell out any gallery across the United States that claims to be showing media art. You're ready to be a successful media artist. But if you want to go to the next level, you got to get Max working with processing. So to do that, we're going to use OSC. OSC stands for Open Sound Control. It's a protocol for applications to talk to each other, basically. In Max, the object for working with OSC is called, there's two objects, one called UDP send and the other called UDP receive. Max is going to be sending, so we'll use UDP send here in Max. So it's called UDP send and not OSC send because UDP is the actual internet protocol, or I guess network protocol, that the OSC packets are being sent over. OSC is how the messages are structured, and UDP is how the network communicates those messages. So UDP send can be used to send messages over the network, so to other machines all across the internet. You can also just use it to send messages between programs on your computer. If you want to just send messages between programs on your machine, you set the host name, which is the first argument, to localhost, which can also be called 127.0.0.1 if you're feeling numerical, if words scare you, which, I mean, Lord knows I've been scared by. There's some scary words out there. And let's set the port to be, I don't know, 6002. Okay, so that's UDP send. The way that UDP send works is create a message box /amp$1, connect that up to UDP send. And finally, let's make a slider, set our slider to be floating point output, range 0 to 1. Move our slider up here, create a floating point box, connect all this business together. Cool. And if I drag this around, it should, yeah, sure enough, these are being sent out of this UDP send. So, what's this /amp business all about? The way that OSC works is all messages have as their first argument what's called a path. Argument would be the wrong word, but the first component of the message is a path, which is a slash followed by where to send that message. And then this first argument, $1, is going to be replaced with this floating point number, which is what's are going to be sent to the place called amp in the receiving application. So this is going to no one right now, but we can define our processing sketch to listen to what's going on here in Max. The way we do that is with a library called P5, or I think it's called OSC P5. And if you are in processing and you come up to sketch, import library, add library, what opens up is this, the library or package manager for OSC. I'm sorry, for processing. It is entirely too awesome that processing has a built-in package manager. I'm not saying I don't like Max 7. The exact opposite is true. But if you're out there, Cycling 74, and you're thinking about Max 8, just saying, a package manager might be pretty great. So anyway, come up here and search for OSC P5. Here it is. I've already installed it, so mine prompts me to remove, but yours will probably say install. So just click on that install button and it will install automatically. And now adding OSC support to our processing sketch is as easy as coming up to sketch, import library, contributed OSC P5, clicking that, and look at that, it actually adds the import headers that are right to the top of the sketch. It's incredible. Simply the greatest thing to ever happen. So let's see, let's get OSC support into our sketch. First we need to declare a variable of type OSC P5, and you can name it whatever you want, but I'm going to name it Oscar because that's hilarious. And then we need to set up Oscar down in our setup sketch. So we'll say Oscar equals new OSC P5. We need to pass it the argument this. I don't really know why. And the port we want to listen on. So in this case, it's 6002. And then we need to call Oscar.plug. And what plug does is define a relationship between the name of the OSC message, in this case it's going to be amp, and the function we want to call with the payload of that message. We haven't defined that function yet, but don't worry, we will in a second. So plug this, the name of the function we want to call is the second argument. I'm going to call it setAmp. And finally, the message that we want to, the path we want to listen to in the OSC message. So in this case, /amp. Okay, and now we just want to define that function amp. I'm going to go public. You got to write public here once again because processing based on Java. Remember, Java terrible. And then void set amp, the name of the function here, float amp. Okay, and now all we're going to do is say intensity, the variable we declared up here, is equal to, amp is going to be a number between 0 and 1, so we'll just say intensity is equal to amp times 10. Cool. And then we'll comment out this line down here and draw so that the intensity is set by this OSC function and not by processing. So if we run the processing function now, run the sketch I should say, we see nothing, just a little point in the center. But if we come over to max and start to move the slider around, look at that. I hope you weren't drinking a hot beverage while I was talking, because how incredible is that? But you know, this is probably good enough to make you an international new media sensation, probably good enough to get you your own show at galleries the world over. But if you want to go even one step further, then the thing to do is add some reactivity, right? You want this patch to listen to sound and send the stuff over to this sketch. So let's see. All we need to do is easy ADC to get sound in. Let's get a meter here so that we know sound is coming in. It is cool. The sound of my velvety and reassuring voice. So let's turn this signal into an amplitude number that processing can use. To do that, I'm going to go to an old standby ramp smooth, ABS. There's lots of different ways to measure signal intensity. The one that I think is going to work best in this context is our good old friend ABS tilde into ramp smooth 1/500, which tends to emphasize transients and the rhythm in the sound, and is good for this kind of application, I think. Yeah, so you can see that as I talk, the processing sketch is reacting to the sound of me speaking. How amazing is that? Processing and Max working together. You never thought you would see it happen, but hey man, in 2015, anything is possible. So I hope that was interesting and informative. There will definitely be some more processing tutorials, processing and Max tutorials in the near future, along with, I promise, some stuff to do with Max 7. Hope you enjoyed, and I'll see you guys next time around. Take it easy.